Welcome to this tutorial on General Purpose Input Output or GPIO. GPIOs are one of the most fundamental and widely used features of microcontrollers. Whether you are working on an IoT projects, automotive applications or industrial automation, GPIOs are essential for interfacing with the outside world. Check out our playlist where we deep dive into Aurix and STM, covering everything from the basic to the architecture. At Cocowatt, we simplify complex concepts to make them easy to understand, especially for the beginners. Don't forget to like, share and subscribe for more insightful videos. Welcome to Cocowatt. In this video, we will first explore what GPIOs are, how they work and their various configurations. We will then take a deep dive into the implementation of GPIOs on the Infineon Aurix microcontroller. This will include register level configuration, real world examples and best practices for using GPIO efficiently. In future videos, we will also explore how to configure GPIOs on other microcontroller families including STM32. But for today, let's start with the basics and build a strong foundation. And remember, this is just the beginning of your journey with Cocowatt Media, where learning meets real-world application. Stay tuned for more exciting tutorial and hands-on project in Cocowatt Media. What are GPIOs? GPIO stands for General Purpose Input Output. Let's understand. When you walk into a shopping mall or showroom, the large glass doors opens automatically to welcome you. Have you ever wondered how this works? Let's break it down. The PIR sensor, which is motion sensor, is input to the microcontroller and doors are the output from the microcontroller. So which is controlled by the motors. So now let's assume like when there is an object is detected, it will give 1 and there is no object, it will give the 0. So now the object is detected, the motion sensor has given 1. Then my microcontroller will process the data, it will identify yes, the object is detected, then door has to open. So using the output pins, it will control the motor to open the doors and after some times it will close the doors. By now you might have understood why GPIOs are important. It provides the interface between external devices and MCU, and also it is very essential to read the sensor data and control the actuators and motors. It enables communication with other devices, real world application of GPIOs. In the IoT devices, it will read sensor data, temperature, humidity and control actuators, fans and heaters. Automotive system, it monitors switches like door locks, ignition and it controls the headlamp motors. In industrial automation, monitors machinery and it controls the robotic arms. In the consumer electronics, it reads buttons and also controls the LED and vibration of the motors. Medical devices read the sensor data and control indicators and alarms. Why GPIOs matters for beginners? Because first step in building real world projects, simple to use yet incredible powerful, fundamental for advanced topics, enables creation of projects from LED blink to IoT systems. Now that we understood what GPIOs are and why they are important, let's dive into the 4 fundamental GPIO modes: input, output, alternative functions and analog mode. Each mode serves a unique purpose and understanding them will help you design efficient and reliable embedded system. In input mode, the GPIO pin is used to read signals from external devices such as switches or sensors. The voltage level at the pin determines whether the signal is high or low. This is incredibly useful when you want your microcontroller to detect user inputs like pressing a switch. Imagine You are building a smart home system. You want to detect when someone pressing a doorbell button. The button is connected to a GPIO pin configuration as an input. When the button is pressed, the GPIO reads a low signal and the microcontroller triggers a notification on your phone. Logic 1. Think this as a yes or on signal. For example, when the doorbell button is not pressed, the GPIO reads high. Logic low. This is like no or off signal. When the button is pressed, the GPIO reads low. Just quick question. What do you think happens if you configure an input GPIO without a pull-up register? Drop your answers in the comments. In output mode, the GPIO pin is used to control external devices like LEDs, motors, buzzers or relays. The microcontroller can set the GPIO pin high to turning on the device or low to turning off the device. Let's say you are designing a smart irrigation system. You want to control a water pump using a GPIO pin configured as an output. When the soil moisture sensor detects dry soil, the microcontroller sets the GPIO high, turning on the pump. Once the soil is sufficiently moisture, the GPIO is set to low, turning off the pump. The logic 1, which is high. This is like flipping a switch to turn on a light. In our example, the pump starts when the GPIO is high. Logic 0, which is low. This is like turning off the light. The pump stops when the GPIO is low. Alternate function mode. Many GPIO pins can also serve multiple purposes. Instead of just acting as a simple input or output, they can be configured for special functions such as communication protocols. Imagine you are building a weather station. You need to collect data from multiple sensors like temperature, humidity, and pressure. Instead of connecting each sensor to a separate GPIO, you can use an alternative function mode to configure GPIO for I2C or SPI communication. This allows you to connect multiple sensors to the same bus, saving pins and simplifying your design. So we have multiple alternative functions like UART, serial communication. Think of this as a conversation between two people. One speaks, that is TX, and other listen, that is RX. SPI, high speed data transfer. This is like a team meeting where everyone talks at the same time, but one person, that is microcontroller, controls the conversation. I2C, sensor communication. Imagine a classroom where the teacher, that is microcontroller, asks questions and student, that is sensor, respond one by one. Analog mode. Some GPIO can also be configured in analog mode. This is commonly used in applications where we need to read real-world analog signals such as temperature, voltage levels, or sensor data. Let's say you are designing a battery monitoring system for an electric vehicle. You need to measure the battery voltage, which varies continuously. By configuring a GPIO in analog mode and connecting it to the microcontroller ADC pin, you can accurately measure the battery voltage and display it on a dashboard. Analog signal. Think of this as a dimmer switch for a light. The brightness can vary smooth, just like battery voltage. And digital signals. This is like a regular light switch. It's either on or off with no battery states. So now you can understand the four fundamental GPIO modes: input, output, alternative functions, and analog mode. In the next section, we will explore advanced GPIO features like pull-up and push-pull registers, open drain configuration, and best practices for designing reliable circuits. Let's talk about an important concept in GPIO design: handling signals when no active input is present. Without proper signal handling, the GPIO pins can float, leading to unpredictable behavior. This is where pull-up resistor, pull-down resistors, open drain mode and push-pull configurations come into the play. Imagine you are designing a security system with motion sensors. If the sensor output is left floating when no motion is detected, the system might trigger false alarms. To avoid this, we use pull-up, pull-down resistor to ensure the GPIO pin stays in a known state when no active signal is present. Pull-up resistor. A pull-up resistor ensures that an input pin stays high, that is logic 1, when it is not actively pulled low. This is especially useful in circuit where a button or switch is used. Let's take a button circuit as an example. When the button is unpressed, the pull-up resistor keeps the input high. When the button is pressed, the input is pulled low, creates a clear high to low transition. Pull-down resistor. A pull-down resistor does the opposite of a pull-up resistor. It ensures that an input pin stays logic 0, which is low when no active signal is applied. For example, some sensors output a high signal when detected an object. A pull-down resistor keeps the input low when no object is detected, preventing floating voltages. This is like a weight that keeps a lower down by default. It ensures the signal stays low when no force is applied. Many controllers offers internal pull-up and pull-down resistor that can be enabled in software when we are configuring as a input. Open drain mode. Now let's talk about open drain mode. Unlike standard output mode, an open drain GPIO can pull the pin low but cannot drive it high. This means an external pull-up resistor is required to bring the signal high. This configuration is commonly used in communication protocol like I2C, where multiple devices share the same data line. For example, in a multi-sensor environment, open drain mode ensures that multiple devices can safely communicate without signal conflict. Now let's discuss push-pull mode. In this configuration, the GPIO pin can actively drive the signal high or low. This is a default mode for most GPIO outputs and is ideal for controlling devices like LEDs, motors and relays. Imagine you are controlling an LED using a GPIO pin in push-pull mode. When the GPIO is set to high, the LED turns on. When the GPIO is set low, the LED turns off. This mode provides strong drive capability and is perfect for applications where you need control devices directly. To summarize, pull-up resistors keeps input high by default, pull-down resistors keeps input low by default, open drain mode allows GPIOs to pull low but require an external pull-up, push-pull mode drives signals high to low, ideal for controlling devices. Thank you for watching. In the next video, we will diving into Aurix GPIO register configuration and a hands-on demo.